Welcome to Classless Subnetting. My name is Stephen Ellis and I work for Warwickshire College and currently a Cisco instructor for Discovery and Exploration, and also IT Essentials and CCNA Security. Okay, so what is Vlsm all about? Well, as previously demonstrated in Classless Subnetting for a C class, which is 192.168.1.0/24, you'll understand the basic principles of subnetting using variable length subnet masks. In this video, all I'm doing is continuing in using a B class. Okay, so how do we do our Vlsm? Okay, as you can see here, I have got two lines on the top here. I have my orange borderline, which denotes each octet as a separate entity. As you can see, it goes from 1 to 128 in each octet. Also, what I have here is I've got my blue line, which is my host line. This is to find out where the line will go on the required host that I need for a particular subnet. You can see the diagram at the bottom here, but the numbers of hosts is a bit difficult to see. So what I've actually done is here I have put my host numbers on the left hand side, and as you can see, I have started with my largest number and finished with my lowest number. This will just help me create my Vlsm subnetworking scheme. Okay, so how do we do it? Okay, first of all, what we need to do is we need to consider only hosts. We're not interested how many networks we need. We're just interested on the amount of hosts that any particular subnet requires. So the way I do it, and hopefully you will do the same, is that I start with my largest amount of hosts that is required, and in this case it is 11,597. So what I do is I use my host line and I navigate along until I can get 11,597 into a number, and as you can see, I can get it into 16,364. even though I must take into consideration the -2. Okay, the -2 represents the first and the last that we can't use, but I can still get it into 16,384 with -2. So what I'm going to do is I'm actually going to draw my line just before the number it will get into. Okay, so it's just before 16,384. Okay, now we know that the start point of any network scheme is always going to be the default network IP subnet. So it will be 172.16.0.0. Okay, now that is our start point, and now we're accommodating for the 11,597. And as you can see by the line, to accommodate this I need to go up in 64. Okay, so the easiest way of getting this done is to actually put that 64 at the start point for the next network. Okay, and as we're working in the third octet, it is the third octet that changes. So let me just put that in. 172.16.64.0. Okay, so that's that done. How many bits have we used for our subnet mask, which is here? Now, as it already states here, we've already used 16 bits, which equates to 255.255.0.0. But we've also used, in this given network here, 2 bits. Now how do we find the subnet mask for this? Yet again, we're only working in the third octet, so we only need to change the third octet. And remember, everything to the left hand side are network bits, everything to the right hand side are host bits of this line. So therefore what we do is we actually add up the bits in this part of the octet. So 128 plus 64 will give us 192. So our subnet mask will be 8 bits, which is 255, 8 bits again, and the 2 bits 192.0, because all of this octet are hosts. Okay, well hopefully you'll understand this a little bit better as we go along. Okay, so now we've actually done this, but what we can do is we can put in the broadcast address. Now the broadcast address is normally, by rule of thumb, the last IP address within this network and the one just before the next network. And as we can see, the next network starts at 64.0. So what we would put in here is 172.168.63.255, because that is the last IP address on this given network. So therefore we can now work out the range. So we find out what the first IP address is after this and the last IP address just before this IP address. Okay, so it's 172.16.0.1 to 172.16.63.254. Okay, and there's your range. So we've actually done that network now. So we can actually erase the line. Okay, and now we're going to accommodate on this network for 1243. So what I'm going to do is I'm going to move along my line again until I can get 1243. Well, I can get 1243 in 2048, so let's draw my line. Okay, done. So what's that telling me? Well, if I go up and have a look at my octet line, you can see we're still working in the third octet and that it's going up in 8, so I need it to go up in 8 to accommodate for the 1243. So first of all, I'm going to add 8 to the 64. So it now becomes the next network start point of 72.0. What is my last IP address of that for the broadcast, which will be 172.16.71.255. So what is the subnet mask now of this given network? Well, if we look at the bits that are on the left hand side, which have now become the network bits, we know by this here 16 that the first 2 octets are 255, and all we do to find out what the third octet is add these up together, which gives us 248. That's correct. And then 0, because remember everything to the right hand side are hosts. Okay, so that's that one done. Now we can put our range in 172.16.64.1, and it's going to go to okay, and that's that one dealt with. So now we can get rid of our line. So just rub that line out. Now we need to accommodate on this network for 597 hosts. So we go along the line again to 597, and as we can see, we can draw our line just before the 1024. Okay, what is it telling us on the top line? It's telling us that we can go up in 4s. So to accommodate 597, I need to add 4 in the third octet. So 172.16.76.0. How many bits have been used? 1, 2, 3, 4, 5, 6. Add all these numbers up together and we get 252 in the third octet. So we know what our first is, we know what our second is, and we've just worked out what our third is. Okay, so what will be the broadcast? That will be the last IP address on this given network. And then we can work out our range. Okay, to 172.16.75.254, 1 just before the broadcast. Broadcast 1 just before the next network. So that's that one completed. So now we can get rid of our line again. So let's just rub that out. Okay, so now what we need to do is accommodate 297 on this given network. Again, we go along our host line until we can get 297. 297 won't go into 256, so we must go to the 512, even though we must minus 2. Okay, so we draw our line here. Okay, how many bits? Okay, because what we'll do is the subnet mask first. So we add all of these up together for the third octet. Okay. So we know what our first is, we know what our second is, and now we know what our third octet is, because all of these added up together adds up to 254. Okay, now we know what it's going up, so it's going up in 2s, so we add it to here. And what's it going up in? Which octet? That's correct, it is the third octet. Okay, so now we can put our broadcast in, because we know the broadcast is going to be 1 below this IP address. So that would be 172.16.77.255. And let's put the range in. And that's that one done. Okay, so now we can get rid of our line again. So we'll just rub that out. Okay, and now for this particular one, we only need 97. And this is where it's going to change slightly. So what we do is exactly the same principle. We move along our host line until we can get 97. And as you can see, we can actually get 97 within the 4th octet. So let's draw our line. And what's it going up in? 128. But what's it going up in? Which octet? So it's the 4th octet. So we don't change the 3rd octet, we just change the 4th octet. So what we do is we go down to the next number and we go 172.16.78 because the 3rd octet hasn't changed, but the 4th has, to 128 as it states here. So therefore the subnet mask, if the 3rd octet are all network bits, it's exactly the same as the 1st and the 2nd. So therefore it will be 255.255.255. Now the fourth octet, we have 128, just one bit, so that will be just 128, and that is our subnet mask for this amount of hosts on this given network. So what will the broadcast be? Well, the broadcast will be one less than this IP address, so it will be 172.16.78.127. okay, and the range one, 2, 172.16.78.126, and that's the range for that one. Okay, so we've actually finished that one now, so I can rub that one out. So let's rub that line out. And what do we require now for this network? So we've got our network start point. Now we have to accommodate 17. So we go along our line again until we can get 17 into a number, draw our line, and what's it telling us? It's going up in 32s in the fourth octet. So let's add 32 to the fourth octet. So it now becomes 160, and as you can see, 128 plus 32 equals 160. Okay, so let's go to the subnet mask of this, and in here we can see that we've got 3 bits to the left hand side in the fourth octet, and the third octet are all network bits like the second and the first, so they're going to be the same. So the fourth octet subnet mask is going to be 32 plus 64 plus 128, which will give us 224. So the first octet is the same, second, third, and there's the fourth octet to denote what subnet mask this network is on. The broadcast is going to be one less than this IP address. And the range is going to be 158. Okay, and that's that one done. So what we can do again is rub out our line. Okay, and now we need to accommodate on this network for 2 IP addresses, and these are exactly the same, so now they'll actually be going up in the same, and they'll be the same subnet mask as well. So how many do we need for 2? Well, we go along our line again, and we can't get 2 into 2 because we must minus this by 2. So our line goes to 4 because 2 into 4 minus 2 equals 2. Okay, so we know what our next start point is going up in. It's 4 in the fourth octet. So this IP address will be 172.16.78.164. The subnet mask, well, if you add these bits up together in the fourth octet, it will give you 252. Okay, the broadcast address will be one less than the next network. And the range will be 'So we've got 2 IP addresses here, 161 and 162, and they would be here your router to router. They will always be stroke 30 or the subnet mask equaling 255.255.255.252, because it is always only 2 IP addresses needed, one here on the gateway and one here on the gateway, which will be serial interfaces. Okay, so that's nice and easy done that. So what is this one? It's exactly in the same place, so we just add 4 again. 172.16.78.168. So what I'm going to do is I'm just going to paste these down, and I'm just going to show you the end result. Doesn't like it for some reason. Let me copy and then paste. Okay, but some of these are going to slightly change, like we've got 164 there. So if I just move this and put in 5 in there and 6 in there, okay, and let's put 7 in there, okay, and if we go to this one, it'll be 169 to 170, and in this one the broadcast address will be 171. Okay, so as you can see, the subnet mask is exactly the same for the whole 3. Now the next start point, if we did want to add another network, we would just accommodate for this 4, and the next IP address available will be 172, and as you can see it's going up in 4, so that would be correct. And that is how easy it is to actually do Vlsm. I hope this has helped you and gained you some insight into how to do Vlsm. But remember, the more you practice, the better you'll get. There is a website called Vlsm.net which will do this for you, but remember, for your practical skills and in case you haven't got internet access, this is the best way of doing it. Thank you for your time.